Okay, Math 043, there's a question about a scientist has two solutions, solution A and solution B, and each contain salt. Now, I'm going to use different numbers here so you can see the example, but in my example, solution A is a 65% salt solution, and solution B is a 92% salt solution. And we want a total of 240 ounces of the mixture that ends up being a 74% salt solution. And the question is, how many ounces of each of the solutions are needed to do that? And round your answer to your 1/10 of an ounce as needed at the end, not in the middle of the problem. So whenever you're setting things up for systems of equations, I usually do an x plus y equals the total, and then I do an x plus y equals, and this will have like the dollar or the percent, whatever the thing is about, and then the total here would be your dollars times your total, or your percent times your total. It's kind of the pattern. So you're going to have, like if it was hot dogs and chips or whatever, you would have like an x plus y equals, we sold 78 of them, and then the hot dogs were $2 a piece, and the chips were 50 cents a piece, and we made $13.70, something like that, where you have x plus y equals a total, and then x plus y equals another total based on what the extra information is for the second equation. So for this one, we're doing percentages. So the first thing we're going to do is x plus y equals a total of something, and then the percentages times x and a percentage times y will give me my wanted percentage times my total. That's going to be the pattern I use for this particular one. So, or A and B, let's use A and B in this case just because they've said solution A and solution B. So my solution A added to my solution B is supposed to give me 240 ounces. So it's A plus B equals 240. Then the next one, we're going to do A and B again, but we're going to put the percentages of the mixture on here. So we said A was a 65% mixture, so I'm going to put the decimal version of that. Remember, it said 65% solution. And then B is a 92% solution, so we'll write that in decimal form as well, 0.92 on the B. And we want the final outcome to be a 74% solution that is 240 for the total, remember, of those ounces. And so here's our two setups. Now we can do this by solving it by elimination. We can do it by substitution. I think elimination would be harder here because you're trying to get either the A or the B to cancel out, and you'd have to multiply everything by certain decimals and stuff. So for my version that I would recommend doing it, solving it by substitution. Like if I would get B alone here, move A over so that we can plug in for B into the problem. Or get A alone. It doesn't matter which one we get alone, okay? Just in my case, I'm going to get B alone. So I'm going to rewrite this top equation. It's going to say B is equal to, I could do negative A and a positive 240, or I could do 240 minus A. Either way is fine. But now I have this set that I can plug into the second equation in place of B, because this says B is this set. So if I put it in here now into the second equation, B is now this, and then equals my 0.74 times 240, and then I would just do the math to solve for A, because A is the only letter that I still have left in the problem. And so if I solve for A, then I can figure out what B is. And so when I do this, I get 0.65A, and then I'm going to distribute this, so it's a negative 0.92A, and a positive 220.8, because I multiply both of those. And then 0.74 times 240 is 177.6. And then I'm going to work towards, I'm going to combine these two right here, 0.92, negative 0.92, and a positive 6.65 is a negative 0.27A. And now that I've cleaned it up, I can start working towards getting A alone. So I'll subtract the 220.8 from both sides. And so I get a negative 0.27A is equal to a negative 43.2. And then divide both sides by negative 0.27. And so A comes out to be 160. Well, if we know we needed a total of 240 ounces, if A is 160, then B has to be the leftovers, which is 80. And you can test it in the problem. You can go in and go, well, if we have 160 times 0.65, 160 at 65% solution, and 80 times the 0.92 solution, does that equal 0.74 times 240? And it sure does.